Welcome to Bhaskarrao Vankalapati Physics. Now we discuss about capacitor. Our question is first question. Four identical metal plates are arranged in air equal distance d from each other. The area of each plate is A. A battery of EMF V is connected across plates 1 and 2. Find the capacitance of the system between points 1 and 2 if the other plates are connected by a conducting wire as shown in figure. So now we clearly observe that here four plates are given. So C and D. C and D are connected by a conducting wire. So according to statement. So now we clearly observe that here between two plates is connected by a EMF battery V. So now we take the potential V across the terminal of potential positive. So here we also there is no electrical element. So here also potential is same. So like that V. So now we take the potential at the end of the negative terminal like that O. So here the potential is like that there is no electrical element. So like that O or 0. So now we clearly observe that. So the distance between any two plates is equal distance d. So that here according to statement given. So we can write the distance between two plates is d. This also equal. So that this one also d. So finally two plates this also distance d. So here observe that and here also designed by using the potential. Here let us assume that the plate of D is like the terminal X. This also take the terminal X. Now we draw the simple diagram for capacitor. So the distance the capacitance between V, O and X like that. Here V and take the O and take the X at the midpoint here. So now we clearly observe that the first between C and V, V and X plates are designed. So that difference V and X, so that here the potential is designed between V and X. So here, so another relay capacitor is also drawn, potential V and O, so that V and O can also drawn another capacitor. Finally, O and X. O and X, the distance between OX potential difference, another capacitor is also designed. Finally, so here clearly observe that the capacitor is converted as following figure. So here the capacitance according to statement given all capacitors are equal. So that this one is the C1, this is one is C2, this one is also taken as C3. So here C1 equal to C2 equal to C3 equal to, let us consider the capacitance is C here. So now we simply calculated the C1 and C2, clearly observe that both are in series combination. So our series combination effective resistance, we know that C effective equal to C1 C2 by C1 plus C2. So that C1 C2 that equal to C into C by C plus C, that equal to C square by 2C, C get cancelled. Finally C effective equal to C by 2. So another capacitance is like that for C effective, both are in parallel combination. The C effective between VO and C3 both are in parallel combination. So finally we get the answer C effective dash equal to C effective plus C3. Already we proved that identified C effective equal to C by 2 plus C3 equal to already we know that C1, C2, C3 also C. So that you can write C. So now we simplify that 3C by 2. So that C effective dash equal to 3C by 2. Already we know that for capacitance for parallel plates C equal to A epsilon naught by D. Already we proved that. So now we can write C effective dash equal to 3 by 2 into C is nothing but A epsilon naught by D. So this one is the capacitance of the given system. Note. Our second question is, four identical metal plates each having area A are arranged as shown in figure. Find the equivalent capacitance of the structure between A and B. So now we clearly observe that there are four plates are given. Here the plate is like that A. So here we clearly observe that there is no electrical element. So here also potential is A. So here from the B side, we clearly there is no electrical element device, so that the potential is here V. So now we take the another capacitance relation unknown, that one is taken as X. So now we clearly and observe simplify the as following diagram, like that parallel and design we draw the between A and B. So take the points A and B, another point is X. So simply, so here from the distance between plate is according to statement is given by D. This one also D. Finally, the between two capacitors is also D. So now we clearly observe the here A and X. Both plates are between A and X. Now we simply design the across the A and X. So this one is also completed. So next here second plates is observed that across A and X. So also A and X another relation, so that we can write the A and X. This one is the parallel combination. Finally, X and B, so that the capacitor is constructed between X and Y. So now we clearly observe that this one is the capacitance C1, this one is the C2, take the C3. So C1 and C2 are in parallel combination. This resultant is series combination in C3. So now we can observe that this one is the C, this one also C. So now parallel combination, both are add them. The effective capacitance for C1 and C2 equal to C1 plus C2, so that C effective equal to 2C. So the resultant 2C is in C3 for C3 in series combination. So that we get the answer C effective dash equal to C1 C effective into C3 by C effective plus C3. So the our relation, so that C effective equal to 2C and C3 equal to C by 2C plus C. Here 2C square, that we can write 2C square by 2C plus C, 3C. So that CC get cancelled. C effective dash equal to 2C by 3. So already we know that for a parallel capacitor C equal to A epsilon naught by D we can write. So that C effective dash equal to 2 by 3 into A epsilon naught by, this is the resultant capacitance from the following figure. Our third question is, three identical metal plates are arranged in air at equal distance D from each other. The area of each plate is A. A battery of EMF V is connected across the three plates as shown in figure. Find the equivalent capacity. So now we clearly observe that here given three plates, the distance between two plates is equal distance. So this one is also D, this one also D. So our first plate is like that A, B and C namely. So here battery is connected across A and C. So and now we take the potential from the positive terminal. Already we know that positive is taken as a potential V. So here towards A we clearly observe there is no electrical element, so that the potential is here also V. Why? Because there is no electrical elements. So now we move towards the capacitor C. Here also there is no electrical elements, so that the potential is also V. But in negative terminal side, the potential is taken as 0. So here also B is 0. So now we simply draw the circuits from the relation O and V. So like that we take the points potential V and O. Here we clearly observe that, so that V and O, so that A and B are relation V and O, so that relation V and O, like that. So now we take the potential V and O are 0, so that A plate and B plates are between VO, so that the plate this one is taken as A and this one is taken as B. Here clearly observe that O and V, B, C are placed, so that this one also take the terms in plates. V, O is nothing but B plate here, and towards the V plate is C, so that CB are here. So both plates are in a parallel combination. So according to statement given, equal capacitance, this one is taken as C1, this one is taken as C2. So that according to statement, C1 equal to C2 equal to C, so that we finally we get the and apply the effective resistance per parallel capacitor, that C effective equal to C1 plus C2. So that C1 plus C2 equal to 2C. Already we know that per parallel capacitor, that A epsilon naught by D we can write. So finally the effective resistance between some plates 2A epsilon naught by D, our answer. Our fourth question equal a parallel capacitor of a plate area A, one plate of which is connected to a spring of force constant K. So in a equilibrium, the plate separation is D due to connection of a battery of EMF V. Find the elongation of the spring. Here spring is connected in the left side of the plate. So now we find out the elongation. So the spring force constant is according statement is given by K. So that we now first of all we find out the charges on each capacitor. So that we know that the relation charge on each plate equal to Q equal to CV. Already we know that our relation. Here C is the parallel plate capacitor. We know that C equal to A epsilon naught by D. So that now we can write Q equal to A epsilon naught by D into V. So this one is the charge on each plate. Now we find out the elongation on a spring. So now we know that according to electrostatic force, that F equal to, so for parallel plate capacitor, F equal to Q square by 2A epsilon naught. So already we prove that. So we can write force F equal to Q square by 2A epsilon naught for parallel plate capacitor force. So already we know that F equal to, we can write elongation for F equal to Kx, spring force constant. So that Kx equal to Q is nothing but here you can write A epsilon naught by D whole square into V by 2A epsilon naught. Finally we simplify that Kx equal to we can write A square epsilon naught square by D square into V by 2 into A epsilon naught. So epsilon naught get cancelled. A get cancelled. So now we can write Kx equal to here another relation A and epsilon naught to V by 2 into D square. That one Kx equal to, now we find out the elongation in the spring, so that elongation indicate the x, so that x can be written as A epsilon naught V by 2k d square. This one is the relation for elongation for giving question. Small correction. Here q equal to A epsilon naught by Vd, so that this one also A epsilon naught by D into V square. So finally get the V square, or can also write the V square. Finally we get the answer x equal to A epsilon naught V square by 2k D square. Our next question is, a capacitor of 5 microfarads connected to a 20 volts battery. When a dielectric slab of constant K equal to 3 is inserted in a capacitor, find the work done by a battery in supplying the excess charge to capacitor. So now we find out the, so in finally work done to carrying the charges from battery. So now already we know that initially charge on each plate before inserting capacitor equal to Q equal to CV. So here C is nothing but 5 micro, so 5 into 10 power minus 6 into potential is nothing but 20, that equal to 100 into 10 power minus 6. This one can be written as 10 power minus 4. So initial charge before insert the dielectrics Qi equal to 10 power minus 4 coulombs. Now after inserting dielectric metal, the capacitance becomes K times increases. So already we know that from theory. So that C dash is the capacitance of the plates after inserting the capacitor. That we can write C dash equal to Kc. So here according to statement given, K is nothing but 3 into C is nothing but 5 into microfarads. So we can write 3 into 5 15 into micro means 10 power minus 6 farads. So now we find out the, after inserting the charge on the plate, Q finally equal to C dash into V. C dash is already, we simplify that, 15 into 10 power minus 6 into V is nothing but 20. So 0, 10 power minus 6 get cancelled, 10 power minus 5. 15 into 2, 30. So we can write 3 into 10 power minus 4 coulombs. So final charges 3 into 10 power minus 4. Initially already for that 10 power minus 4. So now we can write the difference between charges delta Q equal to final charge minus initial charge. So 3 into 10 power minus 4 minus in 10 power minus 4. Here 3 minus 1, 10 power minus 4 can be written as common. So finally 2 into 10 power minus 4 coulombs here. So now we take the work done from the relation. Already we know that potential equal to work done by charge. So now we can write the W equal to V into Q. Q is nothing but delta Q. So here V is nothing but 20 into delta Q is nothing but 2 into 10 power minus 4. 2 0 and 0 get cancelled, 10 power minus 3 here. 2 into 2 4, 4 into 10 power minus 3 joules. Here we can write the formula and relation as follows. 4 into 10 power minus 3 can be written as milli, so that the work done is 4 millijoules according to statement. Solve. Our next question, two identical capacitors A and B are connected with a battery of, now one of these capacitor is filled with a dielectric of dielectric constant K equal to 3. Find the ratio of the sum of energy stored in the two capacitor before and after insertion of insert of dielectrics. So from the following figure, so now we can write this one is the battery, both are two capacitors. So here both capacitors are in parallel combination. So now initial energy can be written as, we know that relation U equal to half CV square. So here C is nothing, parallel combination, so that 2C by V square, we get the answer CV square. And the final energy in the two capacitor U equal to half CV square can be written as second time, but after insert the dielectrics, the C can be written as C plus KC whole square. Here half CV square can be written back common, and we finally half CV square into K plus 1. So here according to statement given, K equal to 3 and 3 plus 1 equal to 4 by 2 is nothing but 2 CV square. So the ratio now according to statement, we now find out the initial energy by final energy, so that CV square by 2 CV square can be written as 1 by 2. This one is the last question for this. Next.